どうも、勝手に電力2.0で始めたいと思います。今日は1128回目というところで、この、Pemetaan, Peluang dan Tantangan, Pengembangan, Industri, Komponen, PLTS, di Indonesia ということで、この Mapping Opportunities and Challenge Development Industry, PLTS, Components in Indonesia ということで、実際にこのインドネシアでですね、この太陽光というところを作っていくにあたって、この太陽光のインダストリーの産業というのをどうやって挑戦していって機会があるのかみたいなところですね、実際に開発していくというよりは、そこに対するその製造プロセスだとか、バリューチェーンみたいなところになってくるかなと思っていますと。まずは Needs Protection and PLTS Components in Indonesia. The Indonesian government's policy to implement a moratorium on the development of new coal-fired power generation projects and the long-term target of net zero emission NZT creates opportunities to maximize the potential of renewable energy, especially solar power. However, until now, Indonesia's electricity supply still depends on thermal power plants thanks to their abundant domestic coal and gas supplies. Based on PLN's LPTL 2021, 87% of the total installed generating capacity in 2020, or 61 gigawatt was thermal power plants. Indonesia, as a country that has abundant solar energy potential, is starting to launch solar power generation PLTS project. Also, PLN LPTL only targets PLTS generating capacity of 4.7 gigawatt in 2030. In doing, the need for PLTS generating capacity has been identified, amounting to 6.5 gigawatts to achieve the target of 23 EBT mix in 2025. One of the efforts to develop PLTS plants is through the National Strategic Project PSN, which targets installed EBT capacity from rooftop PLTS of 3.6 gigawatts in 2025. In an effort to achieve this target, the Indonesian government has established Ministry of Energy and Mineral Resources Regulation number 26 of 2021 as a replacement for Ministry of Energy and Mineral Resources Regulation number 49 2018 concerning rooftop PLTS. Although the old regulations have succeeded in increasing the number of prosumer PLTS users, several revisions to the latest regulations, such as the increase in electricity export price from the original 65% to 100% is expected to accelerate the use of rooftop solar power plants. Furthermore, as the G20 presidency in 2022, the Indonesian government presents a transition plan to new and renewable energy to achieve NZT by 2060. The plan targets an installed PLTS capacity of 361 gigawatt in 2060, around 61% of the total EBT capacity. Basically, the government has identified PLTS as one of the key supporting technologies, achieving NZT setting PLTS capacity targets and starting to implement regulations that encourage PLTS utilization. Therefore, domestic PLTS industry entrepreneurs needs to prepare themselves to be involved in meeting the needs of PLTS installation in Indonesia. Type of industry and condition global supply chain. Monocrystalline silicon solar module production chain. In the last decade, the production of monocrystalline silicon solar module has increased significantly and currently controls 95% of the global market, with production of around 180 gigawatts in 2021. Also, several other types of solar module or cells, such as perovskite and thin film, continue to develop. Monocrystalline silicon 単結晶ですね。Solar module predicted will still dominate the global market until 2030. Therefore, this study is focused on reviewing the monocrystalline silicon PLTS component industry. Monocrystalline silicon is the main material for the making solar cells, which are then assembled in solar modules. This material is obtained through several processing stages for raw material in the form of quartz stone, sand containing silica, SiO2, of the entire process chain from code to solar module. The main industrial components of PLTS are generally divided into four types. The main stages, namely, first, one, polysilicon industry, two, ingot and wafer industry, three, solar cell industry, and four, solar module industry, as shown in figure one. はい、頑張る。This is lantai produksi dan industri lantai pasok modul surya monokristalline silicon di atas posisi dari IEA ってことで、これ実際の作っていく時の工程みたいなところっていうのがどういう工程でいっていくのかっていうところで、実際に物の鉱石を取っていって、そこをシリコンのところの生成をしていきながらモジュール化していくっていうみたいなところになります。Quartz sand produced from mining generally contains impurity elements that needs to be removed to obtain high purity silica, SiO2. The oxide component O2 in silica is eliminated through the carbon thermic reduction process to become metallurgical grade silicon. Then MgSi is further processed through two sequential stages, namely hydrochloration and the Siemens process to produce polysilicon products. Then polysilicon is converted into monocrystalline silicon ingots via the Cholesky process. The silicon ingot is then sliced into very thin wafer on the micrometer scale. In the next stage, the silicon wafer is converted into solar cells through different methods. The type and amount of treatment, such as doping, etching, etc., determine the type of solar cell technology produced. Several types of solar cell technology are currently known, including BSF, monoparks, TOPCon, and so on. The solar cell then need to assemble together with several module supporting components such as aluminum frame, protective glass, encapsulating polymers, backsheet, and junction box so that it becomes a solar module as shown in figure 2. コンポーネント、ペニュースン、モデルスリアということで、太陽光というのはこの今のランカ、アルミニウムっていうところと、カチャ、プルリンドゥンっていうところ、シートのところと、ポリミ、エンカプルラシシートとセルスリアとセルがあって、バハン、エンカプスラシ実際のものがあって、バックシートがあって、コタックジャンクションということで、ジャンクション箱があると。コンポーネント、プニュースン、モデルスリアということで、apart from the main industrial components so that solar module can function optimally as a PLTS system, several essential supporting components are also needed, which are often referred to as balance of system BOS, which include inverters, cables, modules, supports, and energy storage. Manufacturing of these four components in this report is hereinafter referred to as the PLTS supporting components industry. Global supply chain conditions for main components of PLTS, commitments and policies to reduce GHG emissions through PLTS in many countries, especially China, India, the European Union, are the main drivers of increasing demand for PLTS installation. The International Energy Agency (IEA) reports that global PLTS demand in 2021 will also reach 200 gigawatts, exceeding previous projections of between 120 to 140 gigawatts. With the increase, the world electricity supply needs will reach 2,700 terawatt-hour per year in 2025. Demand for PLTS components is predicted to continue to increase. At the time when there is an increase in demand for PLTS installations and the production capacity of industries in the main PLTS component supply chain, such as the polysilicon wafer and solar cell industries, global solar module prices show a downward trend of around 80% during the 2010 to 2020 period. However, in 2021, there will be an increase in the average price of solar module due to an increase in the prices of commodities made from glass, silver, and silicon, as well as an increase in transition costs, which were not caused in the COVID-19 pandemic. However, the price of solar module is predicted to show an downward trend again through innovation and increased efficiency in the production chain, which has been continuously developed. 実際にちょっとだけコストが上がったりしたんですけど、やっぱりイノベーションとかでどんどん下がっていくっていうところを書いています。As shown in Figure 3, industries in the solar module supply chain, except the polysilicon industry, have production capacity that are much higher than market demand in 2021. The tight gap between demand and supply for the polysilicon industry is one of the impacts of the shutdown. Polysilicon manufacturers in several countries in the 2010 to 2015 period were unable to compete with manufacturers for China. At the end of 2021, polysilicon manufacturers concentrated in China were affected by the pandemic and caused global supply disruptions, so that the price of polysilicon increased 4 times and reached USD 35 kilogram. Currently, more than 80% of the market share of the main PLTS components, polysilicon to solar module, is dominated by China. It is predicted that China's dominance will continue with the presence of several PLTS industry facilities still under construction in the country. On the other hand, only about 40% of total installation requests globally originating from the PRC. Both of these imply that approximately 40% of global solar PV component supply demand are PRC manufacturers. The concentration of the PLTS components supply chain in one country can be a problem for countries that have declared energy targets and PLTS installation, including Indonesia phenomenon. The increase in global solar module prices in the last 2 years in an indication of the importance of preparing for an independent supply of PLTS components, at least to meet domestic needs. 実際にこの、まさにチャイナっていうところがどれだけどの部分で占めているかっていうので分かると、モジュールっていうところとセルでも、実際にユルフェアのポリシリコンの段階でも、言っているっていう状況です。で、このストラクチャル biaya proyek PLTS scala unilitas っていうところで、実際にどのくらいの、モジュールとある量がいるのかっていうところですよね。っていうところの、インドネシアもそろそろかなり上がってきているという状況です。Cost. An inverter is an electronic device in a PLTS system that converts DC direct current electrical energy produced by solar cells in AC alternating current electrical energy so that it can be used in the electricity network. Inverters come in various types and are generally differentiated based on their power rating in 2021. Inverter with small-medium power, the string type, which is generally used in home or small and medium commercial solar systems, has a market share of around 64%. Meanwhile, central type inverters, which are generally used for large-scale or commercial-scale PLTS systems, have a market share of around 34%. The inverter consists of semiconductor power, economic components, power block, and passive components. These components are usually manufactured separately and will be combined to become an inverter. In 2020, global inverter production is estimated at 185 gigawatts, of which 66% of capacity is produced by Chinese manufacturers. Apart from the inverter, supporting components of the PLTS system that is no less important in the battery. Utilization of solar energy in the form of PLTS, especially in standalone PLTS system off-grid, requires battery for operation. The types of batteries generally used in PLTS systems are lead-acid and lithium-ion batteries. Lead-acid batteries are battery technology that has long been commercialized, which lithium battery technology is relatively new and has been intensively developed in recent years for the electric vehicle industry. With no large companies dominating it, the battery industry market is currently an open market. Even though the use of battery is often found in PLTS systems, information regarding the installed battery capacity and type is not available, especially in small PLTS systems such as those on the household scale. By 2017, installed battery capacity for the global energy sector was estimated to have reached 10 gigawatt-hour. Meanwhile, the total world battery demand for the sector electricity is estimated to reach 159 gigawatt and 1,046 gigawatt in 2030 and 2050, according to the current policy scenario. The cable in the PLTS system, which functions to connect several solar modules and supporting components, must have resistance to ultraviolet radiation, high temperature, and various weather conditions. The cable used in PLTS systems are generally divided into three types, namely DC solar cables, which are usually used as a connection between solar modules, main DC cable, which are the connection between the solar module and the inverter, and AC connecting cable, which are used to transmit electricity from the inverter to the network. AC electricity selection of the size and type of cable material is very important in the solar PLTS system to ensure system safety and electricity transmission efficiency. However, a study of the cable industry supply chain explains the need in detail. Cables for PLTS systems are still very limited. Cables for PLTS systems generally must meet the standard contained in the National Electric Code (NEC) of each country. Several countries already have the industry and the ability to produce cable components for PLTS system needs. The support structure in the PLTS system functions to maintain the position of the solar module at the optimum angle for sunlight. Therefore, the module supports must have a strong mechanical structure against wind. In addition, the support structure needs to have space for air circulation and can be equipped with tracker so that the solar cells operate more efficiently. The support structure of ground-mounted PLTS is generally made of stainless steel. Meanwhile, floating PLTS requires a floater component. Currently, there are many global suppliers of fixed title type support due to their low market barrier to entry with minimal patent or intellectual property related to support design. Module support structures for solar PV projects are usually manufactured close to the installation location or supplied directly by the solar module manufacturer to reduce shipping costs. Proyeksi kebutuhan komponen PLTS di Indonesia. Kebijakan pemerintah Indonesia untuk melakukan moratorium terhadap pengembangan proyek pembangkit listrik berbahan bakar batubara baru dan terjangka panjang net zero emission NZT menciptakan peluang untuk memaksimal potensi EBT terutama tenaga surya. Akan tetapi hingga saat ini pasokan listrik Indonesia masih bergantung pada pembangkit listrik termal berkat melimpahnya pasokan batubara dan gas dalam negeri. Berdasarkan RPTRPPRN sebesar 87% dari total kapasitas pembangkit terpasang pada tahun 2020 atau sebesar 61 gigawatt merupakan pembangkit listrik termal. Indonesia sebagai negara yang mempunyai potensi energi surya yang melimpah mulai mencanangkan proyek pembangkit listrik tenaga surya PLTS meskipun PLN hanya menanggetkan kapasitas pembangkit PLTS sebesar 4 gigawatt pada 2030 dalam ruang RUKN telah teridentifikasi kebutuhan akan kapasitas pembangkit PLTS sebesar 6 gigawatt untuk mencapai target 23% bauran EBT di tahun 2025. Salah satu upaya pengembangan pembangkit PLTS adalah melalui proyek strategis nasional yang menargetkan kapasitas EBT terpasang dari PLTS atap sebesar 3 gigawatt pada tahun 2025. Sebagai upaya mencapai target tersebut, pemerintah Indonesia telah menetapkan Permen SDM nomor 26 tahun 2021 sebagai pengganti Permen SDM nomor 449 2018 tentang PLTS atap. Meskipun regulasi yang lama telah berhasil meningkatkan angka pengguna prosumer PLTS, beberapa revisi pada peraturan terbaru seperti pada kenaikan harga ekspor listrik dari semula 65% menjadi 100% diharapkan dapat mengakselerasi pemanfaatan PLTS atap. Lebih lanjut, pada presidensi G20 tahun 2022, pemerintah Indonesia menyampaikan rencana transisi ke energi baru dan terbarukan untuk mencapai NZT di tahun 2060. Rencana tersebut menargetkan kapasitas PLTS terpasang sebesar 361 gigawatt di tahun 2060, sekitar 61% dari total kapasitas EBT. Pada dasarnya, pemerintah telah mengidentifikasi PLTS sebagai salah satu teknologi kunci dalam mendukung pencapaian NZT, menetapkan target kapasitas PLTS dan mulai mengimplementasikan regulasi yang mendorong pemanfaatan PLTS. Oleh karena itu, pelaku usaha industri PLTS dalam negeri perlu mempersiapkan diri untuk terlibat dalam pemenuhan kebutuhan instalasi PLTS di Indonesia. Jenis induksi dari kondisi lantai pasok global, lantai produksi modul surya silikon monokristalin. Dalam satu dekade terakhir, produksi modul surya berjenis silikon monokristalin mengalami peningkatan yang signifikan dan saat ini menguasai 95% pasar global dengan besaran produksi sekitar 180 gigawatt di tahun 2021. Meskipun beberapa jenis modul atau sel surya lain seperti perovskite dan thin film terus berkembang, modul surya berjenis silikon monokristalin diprediksi masih akan tetap mendominasi pasar global hingga tahun 2030. Oleh karena itu, studi ini difokuskan untuk menguras industri komponen PLTS berjenis silikon monokristalin. Silikon monokristalin merupakan material utama untuk membuat sel surya yang kemudian disusun menjadi modul surya. Material tersebut diperoleh melalui beberapa tahap pemrosesan dari bahan mentah berupa batu pasir kuarsa yang mengandung silika dari seluruh lantai proses dari kuarsa menjadi modul surya. Jenis industri komponen utama PLTS umumnya dibagi menjadi 4 tahapan utama, yaitu 1. Industri polisilikon, 2. Industri ingot dan wafer, 3. Industri sel surya, dan 4. Industri modul surya seperti ditampilkan dalam gambar 1. Pasir kuarsa hasil tambahan umumnya mengandung elemen pengkotor yang perlu dihilangkan untuk memperoleh silika. Kemurnian tinggi kandungan oksida dalam silika dieliminasi melalui proses reduksi karbotermik menjadi silikon material grade. Kemudian MGC diproses lebih lanjut melalui 2 tahap berurutan, yaitu hidrolakisi dan proses Siemens untuk menghasilkan produk